The first time I saw a Megalodon tooth in person, it wasn't in the ocean. It was sitting in a display case, black, serrated, the size of my hand. And what unsettled me wasn't just how big it was where it had been found, high and dry, in rock that used to be ancient seabed, now lifted into hills far from any coastline. A fragment of a mouth that no human has ever seen alive. A jaw that could have swallowed a grown person whole. We call it a giant shark. That's not accurate. Megalodon wasn't just a bigger version of something we know, it was a predator that rewired entire ocean ecosystems. A 15 to 20 meter force of muscle and teeth that shaped the behavior, migration, and evolution of whales. It didn't just live in the ocean, it engineered it. And when I started looking closer, I realized something else. Nothing about the Megalodon is normal. Not its size, not its power, not even the way it vanished. Before we even talk about the real Megalodon, we have to deal with the shadow version, the one that lurks in internet forums, the one supposedly hiding in the Mariana Trench, the one crunching submarines in viral videos. I used to find those stories entertaining, the idea that something that big might still be down there, waiting. But here's the problem. Megalodon lived between roughly 23 million and 3.6 million years ago, during the Miocene and early Pliocene, long before humans, long before the ice ages fully gripped the planet. And we don't have a single credible fossil younger than that. Sharks are almost entirely cartilage. They don't fossilize easily. What we find are teeth, lots of them. Over 20,000 teeth in a lifetime from a single individual are constantly replaced. That's why Megalodon teeth are relatively common in certain deposits. But that's also all we have. No complete skeleton, no preserved body. Everything we know is reconstructed from teeth, vertebral fragments, and bite marks carved into fossilized whale bones. Size estimates vary because they have to. Scientists compare tooth size to modern sharks, especially the great white, then scale upward. The most widely accepted estimates place Megalodon at around 15 to 18 meters long. Some argue it may have reached 20 meters. That's roughly the length of a bowling lane. Its bite force, models suggest up to 100,000 to 180,000 newtons. For context, a modern great white might generate around 18,000 newtons. A lion produces around 4,000. Megalodon wasn't twice as strong. It was in another category entirely. When people imagine it lurking in deep trenches today, they're picturing a creature designed for a world that no longer exists. The ocean was warmer 15 million years ago. Sea levels were higher. Whale species were different, smaller, more abundant in coastal nurseries. Megalodon wasn't hiding in the darkness. It dominated warm, shallow seas across the globe. Fossils show up on every continent except Antarctica. It wasn't a ghost of the abyss. It was the ruler of sunlit coasts. Here's where things get strange. We don't actually know exactly what Megalodon looked like. The popular image, an oversized great white, is partly assumption. It's based on tooth shape and serration patterns. Megalodon teeth resemble great white teeth, just scaled up. That suggests a similar feeding strategy, slicing through flesh and bone. But more recent studies propose something even more extreme. A bulkier body, a wider head, a thicker torso built for bursts of crushing power rather than speed alone. If a great white is a torpedo, Megalodon may have been a battering ram. Imagine a 50-ton animal accelerating toward a whale calf, not just biting, colliding. Its teeth weren't designed to delicately pierce. They were triangular, serrated blades, perfect for cutting through blubber and snapping ribs. Fossil whale bones show deep gouges consistent with enormous, shearing bites. In some cases, vertebrae appear crushed. This wasn't a nibble and wait predator. It was built to dismantle. And here's what makes that even more unsettling. Bite force alone doesn't tell the full story. Jaw mechanics matter. Megalodon's jaws likely opened nearly 2 meters wide. That's large enough for a human to stand inside. But what strikes me is efficiency. A predator that size can't afford to waste energy. It would have targeted high-calorie prey, marine mammals rich in fat, early baleen whales, toothed whales, possibly even large seals. There's fossil evidence of juvenile whale bones with bite marks suggesting predation rather than scavenging. Some researchers believe Megalodon may have targeted flippers first, immobilizing whales before delivering a fatal bite to the chest cavity. That's strategy. That's system-level hunting. And the deeper I look at its anatomy, the clearer it becomes. This animal wasn't just big. It was engineered by millions of years of escalation between predator and prey. It evolved into something the ocean had never seen before. We tend to think of ecosystems as bottom-up. Plankton feed fish, fish feed bigger fish, whales roam freely at the top. But when you introduce a predator the size of Megalodon, the entire structure shifts. Modern orcas changed the behavior of seals and even influence kelp forest health through trophic cascades. Now imagine that effect amplified by an animal 3 times longer than an orca. Early whales during the Miocene were diversifying rapidly. Some were smaller than modern species. Some likely used warm coastal waters as nurseries. If you're a whale mother in that world, where do you give birth? Not in deep open water where a 50-ton shark can approach from below. You choose shallow, protected areas. Fossil evidence suggests certain whale species may have shifted birthing grounds closer to shore during Megalodon's reign. That's behavioral pressure. That's evolutionary pressure. Megalodon wasn't just eating whales. It was shaping where they lived, how they migrated, and potentially how large they grew. Some scientists hypothesized that as whales increased in size over time, growing beyond what Megalodon could easily subdue, it may have been partly a response to predation pressure, an arms race. And when a predator that size patrols coastlines, scavengers benefit too. Carcasses left behind feed entire communities of smaller sharks, fish, and invertebrates. One Megalodon kill could ripple outward through dozens of species. It was an apex predator, but it was also an ecosystem architect. This is the part that fascinates me most. How does something that dominant vanish? Extinction isn't usually dramatic. It's slow, gradual, a tightening vice. Around 3 to 5 million years ago, global climates began cooling significantly. The Isthmus of Panama closed, reshaping ocean currents. The planet entered a period leading toward the ice ages. Sea temperatures dropped, warm, shallow seas shrank, prey distributions shifted. At the same time, whales were evolving. Many species grew larger, faster, and more migratory. The kind of prey Megalodon specialized in may have become harder to catch. And then new competitors appeared. Modern great whites emerged, smaller, more agile, better adapted to cooler waters. Early orcas evolved into coordinated hunters capable of targeting large prey in groups. Imagine the vice tightening, less warm habitat, shifting prey, new competition. An animal that requires massive caloric intake cannot survive long-term decline in food supply. A predator at the top is the first to suffer when the base shifts. Megalodon didn't need to be wiped out overnight. It only needed the balance to tip slightly out of its favor. And slowly, generation by generation, it disappeared. We still find its teeth, blackened by minerals, buried in riverbeds, cliffs, beaches. Scientists analyze isotopes within those teeth to infer water temperatures where individuals lived. They examine wear patterns to understand diet. They study bite marks on fossil whale bones to reconstruct attack strategies. But we have no modern sightings, no deep-sea footage, no carcasses. An animal that large would leave evidence. Whales strand, sharks are caught, DNA traces appear in water samples. The ocean is vast, but it is not infinite silence. The idea that Megalodon survives today often leans on the mystery of the deep sea. We've explored less than we'd like, but Megalodon wasn't adapted to trench life. Its prey base doesn't exist in those depths. Its physiology was built for warm coastal ecosystems. There is no ecological niche waiting for it in the modern ocean. Instead, its absence leaves something else. Today's apex predators, great whites, orcas, are formidable, but none operate at the scale Megalodon did. There is no single predator now capable of reshaping whale evolution the way it once might have. The ocean feels immense to us, but compared to its past, it may be quieter. When I look at a Megalodon tooth now, I don't see a movie monster. I see evidence of a world that was more extreme than we're comfortable imagining. A world where whales were hunted by something the size of a bus, where coastlines weren't safe nurseries, but hunting grounds patrolled by jaws wider than a doorway. And I'm reminded of something humbling. No matter how powerful a species becomes, it exists within a system. Climate shifts, currents change, prey evolves, competitors emerge. Even the most dominant predator in Earth's oceans can vanish. What other giants have come and gone without leaving more than fragments of teeth? How incomplete is our picture of ancient seas? How small is our mental map of what the ocean has truly been? Nothing about Megalodon was normal. Not its scale, not its influence, not its disappearance. And maybe that's the point. The history of this planet is far more extreme than we think, and we've only just begun to understand it. If you enjoyed this film, I'd truly appreciate your support. These projects take time, research, and a lot of care to bring ancient worlds back to life. If you want to see more deep explorations like this into vanished giants, lost oceans, and the strange rules that shaped them, consider subscribing, leaving a comment, or sharing this with someone who loves the unknown. And if you're ready to go deeper, I think you'll love the next film waiting right here.